To build a city on the moon, we first have to defeat Earth's gravity well. Lifting heavy construction materials like concrete and steel into orbit requires an enormous stack of fuel just to move a tiny payload, a mathematical barrier known as the rocket equation. Despite this cost, China and Russia have formed a coalition to establish the International Lunar Research Station by the 2030s. A permanent base of this scale requires heavy infrastructure, pressurized laboratories, life support systems, and massive radiation shields. Launching all of that mass on rockets is too expensive for any single nation to sustain. To make a lunar city economically viable, we have to stop shipping building materials from Earth. The solution is a strategy called in situ resource utilization, or ISRU. It means living off the land and manufacturing everything from the moon's native dirt. To survive on a hostile celestial body, human outposts require three distinct pillars: physical shelter, consumables like air and energy, and the labor to build it all. China is now systematically engineering and testing solutions for all three, developing the specific technologies required to bypass the earthbound supply chain. Take shelter. Chinese researchers are using a high-heat process known as sintering to melt simulated lunar dust and press it into interlocking Lego-style construction bricks. Because the lunar surface fluctuates wildly in temperature and lacks an atmosphere to block meteorites, these blocks are engineered to be over 3 times stronger than standard Earth bricks. To prove they hold up, 74 of these bricks were sent to the Tiangong space station. They spent a full year mounted outside the station, enduring extreme cosmic radiation and brutal temperature swings. Those bricks recently returned to Earth. Upon close inspection, researchers confirmed they survived the year in a pristine, structurally stable condition. By proving the durability of these blocks, engineers can 3D print entire habitats on the lunar surface without importing a single ounce of steel. Once a habitat is built, the astronauts inside need breathable oxygen, and the rockets returning them to Earth need fuel. We can see the solution in this actual pile of lunar soil, brought back to Earth by China's Chang'e 5 mission. Scientists analyzed this dirt and discovered that a specific compound within it, magnesium silicate, acts as a highly efficient electrocatalyst, a substance that speeds up chemical reactions using electricity. This elemental map breaks down the sample's chemical makeup. By loading the magnesium silicate with copper, researchers trigger a reaction converting carbon dioxide into methane rocket fuel. Simultaneously, this electrocatalytic reaction strips away atoms to produce breathable oxygen as a direct byproduct. Lunar dirt isn't a dead obstacle, it's a source of the raw chemicals needed to maintain a permanent settlement. But running chemical reactors and hauling heavy bricks across the lunar surface is incredibly dangerous for human astronauts wearing bulky pressurized suits. Instead of risking human lives, China is deploying embodied AI, advanced artificial intelligence integrated directly into physical robots that can adapt to unpredictable extreme environments. Their solution is the Chinese Supermason, a specialized robotic system designed to autonomously scoop up raw lunar soil, 3D print the interlocking bricks, and operate chemical reactors completely unmanned. Humans will not be the primary builders of this moon base. They will arrive as the inhabitants of a city constructed entirely by machines. This technology is an active industrial pipeline right now. In 2028, China will launch the Chang'e 8 mission. Its objective is to deploy a Supermason robot to physically manufacture the very first lunar brick directly on the surface of the moon. By the early 2030s, years before the first human crews arrive, a silent, autonomous robotic factory will already be active. It will be building habitats, generating breathable oxygen, and stockpiling methane fuel. China is establishing an automated industrial presence on the moon, a move towards long-term operational resilience that bypasses the limits of traditional human-led space exploration.